Good afternoon, fancy meat computers. How is everybody doing today? Hope you're all doing okay. Everything is fun and happy. Happy fun times. Alright. So, let me see if we have any announcements today. Doop-a-doop-a-doop. Tutorials survey. There's one for you. There we go. So, hi everyone. This is from Sarth. As we move back to in-person tutorials next week, we wanted to make sure you are finding these tutorials helpful so far. So if everyone could please take a 2 to 3 minutes, if everybody could please take out 2 to 3 minutes and fill out the very quick and anonymous tutorials survey, which can be found in Resources Surveys, it would be highly appreciated. I know it's early on in the semester to have a certain opinion, but your feedback will help us, TAs, improve the tutorial for the rest of the semester. In the meantime, good luck finishing Assignment 1, due this Sunday at 11:59. And that was posted yesterday. How am I? How am I? I'm doing well, thank you. Everything's just kind of, I'm doing okay. My wife told me that the weather report indicates that overnight temperatures are going to dip down to minus 30, 35, which is damn cold. If you've never experienced minus 30 in your life, I recommend suiting up around midnight and just experiencing it, It's like an experience to be in weather that's that cold. Unless, of course, you're from Alberta, in which case it's Tuesday. Do you know when we're supposed to get the marks back for A1? I just submitted it and thought the autograder would mark it right away. No. So how the assignments work, we still have to collect, that's not how the Jupyter system works. We still have to collect up all the assignments, and Sarth has to turn the crank on the autograder to actually mark all of the assignments. And furthermore, generally speaking, we do not give people grades until there's no, you don't get a grade until after the due date, because you can run with your correct solutions to someone who hasn't submitted yet and be very tempted to plagiarize with them. So, yeah, no. Furthermore, because of the now extended MSAF lockout period, we can't actually turn the crank on the autograder until the following Friday, because we have to wait for all the MSAFs to come in, too. So, there you go. Lectures will be starting in person next week, correct? Correct. I didn't believe it. For a long time, I didn't believe that it would actually come to pass, and I suppose they still have time to cancel it, but, yeah, I guess we are in person next week. So, we'll see how that goes. I'm much more fun in person, by the way. Minus 30, yikes. Minus 30 to 35, my friend. Vancouverian shivering already. Yeah, really. Just make sure you got lots of blankets. Will Mark's tutorial still be recorded? Yes, so we're going to continue to do the online virtual tutorial section, primarily for the benefit of those who have to stay away from the university in case they're isolating due to the whole COVID thing. But yeah. It says assignment 2 is due on the 13th, but it's actually the 6th. What is it? Is that Avenue that says that? Because if that's Avenue, then we can fix that right now. Oh yeah, the whole enchilada has to be fixed. Yeah. Alright. Let me just shoot a quick message to the TAs about that. There we go. That should be done as when somebody gets around to it. Good. Will the lectures still be recorded? Yes. Yeah, we're going to still be recording the lectures. Yes. Yeah. My wife bought me a camcorder for Christmas. So I'm going to be using, or, one of the TAs is going to video record the lecture, and we're going to see how that goes. Probably the quality will take a little bit to iron out, but hopefully it'll be legible. But yeah. Anyway, so that's everything. We've got to keep moving on this lecture material, so we'll get right into it then. Right? So, yeah, when in doubt, the syllabus trumps all other sources of information. But if you're unclear about anything, please get in contact with myself or anybody on the grade team. So, last time we were talking about strings. We were talking about string slicing. We had actually talked about all of the operators on this page. So, terminal. Well, I'm not sure I gave you an example of count and index, but they're easy, so, and we have to keep moving, so. There we go. So, let's keep going. So, strings are immutable. We've talked a little bit about what it means for a data structure to be immutable, but essentially that means you can't change the individual characters inside of the string without creating a new string. Yeah. So, essentially, you can't take a string, say any string, like S is equal to people should try coming to class. You can't say S at 4 is equal to an capital F and have that work, because capital F is what the people who don't come to class will get. Nah! Jokes about grades. So, similarly to tuples, we also have concatenation. We have substring search, or we can call that a test for membership. But we've got a couple of interesting ones as well. So, or a couple of ones we haven't talked about yet, anyway. So, it's kind of fun. Concatenation with strings is very easy. So, it's like, try again next semester. There you go. I'm being mean. I should stop being mean. I'm considering coming to class watching the lectures here. So we've also got a test for membership. So you can say, if this is S, we can say P in S, true. Lowercase p in S, also true. You can also test like a whole substring. So if you wanted to see if the word try is in S, that would work. But also keep in mind that if you have that's not a test to see if a word is in there. That's just a test to see if these three characters in the same order are in the string, right? So something like rustry would also work. Or, if you want to come up with a word like that. So if you want to test to see if it's an actual word, what you do is you include spaces on either side. So in that case, it would be false, but if you did that with the string S, it comes out true. Test for the spaces. Don't think that spaces aren't important. Spaces are super important. You can also repeat stuff using multiplication, which is kind of fun. So if you want to make the computer scream, There you go. You can even make this ridiculously large. And just fill the screen with ah! Yeah. Is fail in S? What is S again? Yeah. Well, you know. That's the difference between meat space and computer space. You can also test for a suffix, which comes in very handy when you're trying to work with file extensions, right? So when we get to file IO, the way that you'll have to transmit the file name of a file that you want to open, or open for reading or writing or whatever, is using a string, and you can test to see if, like, my file.py, you can see if it's for example, text file by saying ends with .txt. Oh, maybe they got rid of it. Oh, ends with. There you go. False. .py. True. There you go. Yep. So. If you think that A is becoming strange to you, you should try Cyrillic. So I'm not going to patronize you guys by re-explaining what print does, but input might be an interesting thing for you to see how to do, right? So I have to put a disclaimer in front of this. While input is a very useful and interesting function, and is used for, a lot of different things, at no point will we ask you to use it during the assignments. And there's good reason for that. Basically, it gums up the autograder. You'd have to have a TA, like, sitting on top of, just because of the way the Jupyter system works, you'd have to have a TA sitting on top of the terminal session in which the autograder was running, and, like, manually entering all of the input that's supposed to be if you were using input, the input function, which of course completely defeats the entire purpose of autograding. So, don't use input for your assignments, but here's what it does. If you assign the results of input to some variable, you can say something like, how many watermelons would you like? How many watermelons would you like? I would like 10 watermelons. X is 10. There you go. You can run, like, fun little scenarios with this. Basically, now that I've shown you this, you have all of the code that you require in order to make text adventure games. Like Zork. So, good. So let's talk about string formatting. You can use the .format function to format numbers and other values as strings. So, essentially, what you have to do is you have to leave space inside of the string that you want to insert information into using curly braces, and then you can insert stuff into a string that way. So, for example, my name is string. I am D years old, and I have bitcoins. So then you called format on that, and you provide the things that you want to insert there. So, for example, my name is Bartholomew, I am -6 years old, and I have 0.1 bitcoins. So you can see it just inserts these things. It finds these holes in the string, and it inserts the appropriate information into them. But the interesting thing that you can do with this is you can use some of the special formatting features that you find in other languages like C to perform a little bit of formatting on the things that you're inserting. So you'll notice that we get 6 decimal places by default when we print a floating point number. If you want to decrease the number of decimal points that you get, you specify the number of decimal points by going point and then the number. So if you want 3, it looks like that. If you want, for example, 60, there you go. And you can see that 0.1, what you thought was 0.1, actually has some garbage at the end of it if you let it print itself long enough, which contributes to that problem with 0.1 being added together 10 times not equaling 1. Good. So, here are a couple of examples. The frequency function here counts the number of occurrences of the argument t in the string s, and then displays that as a percentage, right? So if I were to say define frequency st, return s.count t, divide by the length of s, multiplied by 100. Operations are left associative. Then, and if x is equal to there we go, a bunch of f's and j's. The frequency in x of j is 41%, f is 58%, and x is 0%. The word SDF can be chosen randomly chosen. What do you mean by the word? Oh, here you mean. Well, I wouldn't say exactly randomly. It's basically governed by the same types of rules that you would use to determine the names of variables, right? It should be representative of the of whatever it is that you're operating on. So in this case, s is a string, and t would be, I guess, I'm not sure where they're deriving t from here, but yeah. Like for example, here w represents word. You'll find that most of the arguments that are provided for you in the assignments are more verbose than this. Did I have to tab before return? Yes. So Python determines what is inside of what by indentation, right? So this return statement is applied to this function because it's been tabbed in by 1. If it wasn't tabbed in by 1, then it wouldn't be part of this function. That would be a syntax error. No, I mean for the format function. Oh, no, these are specific tags that mean specific things. S is string, D is integer, F is float. You're constrained to use the characters that are indicated. Basically, the character specifies the data type. So if you mess up the character, you mess up the data type. Yeah, cool. Good. Yeah, you'll get used to tabbing. We haven't really talked about it because we haven't the next set of slides is all about statements, and then we're gonna learn how to put a bunch of this stuff together. So plural is another function. All that does, it returns W with ES on the end if W already ends with S. Otherwise, it just adds one S to the end. So duck would become ducks, D-U-C-K-S, and walrus would become walruses, W-A-L-R-U-S-E-S. There you go. We've talked about it, I think I talked about it like maybe once during the snow day lecture that wasn't actually a lecture. But if you want to, like, we've talked about if statements quite a lot. If you want to take an if statement and compress it into an expression so that you can fit it all in one line, this is the way you do that. You say, let's say we had some variable v is equal to 9, and we want to say z is equal to 8 if v equals 3, else 10. What is z? It's 10, because v is not equal to 3. However, if v was equal to 3, z would be taking, it would take the first one. So basically, it's kind of like, this is easier if you read it like from the middle, like read the line from the middle outward rather than left to right, which is usual. You take the first case if this thing comes out true. You take the second case if this thing comes out false. I don't really expect you to use these things because for me, using if statements in statement form is more clear and intuitive for a beginner. And presumably most of you are beginners, or else why would you be in this class? So there you go. You can use this if you want, but, you know, I think they got T just because the function seems to be written to identify the percentage of strands of DNA is made up of nitrogen base thymine. Yeah, but it doesn't just work on thymine, right? If you used an A there, you would get adenine. If you used a G, you would get guanine, and if you used a C, you would get cytosine. So I don't know why, like, if that's the reason, that's a bad reason. It should say base, right? I would put base there, but yeah. Okay, good. So let's talk about Boolean operators. So Booleans are true or false values, right? You can combine Booleans together in order to make more complicated expressions. This is normally done with like comparators rather than truth literals, because that's kind of, what's the point of doing it with a truth literal? Is my face mostly obscured by the... There. This is perhaps a bit better. You can see my mouth moving, which is kind of the whole point. So, let's say you had two conditions, right? Let's say, going back to v and z, let's say v is less than 6 and v is greater than 10. This can never be the case, right? This is always going to be false. However, what is v again? 3? Yeah, okay. So if I say or, essentially, if this condition or this condition comes true, then the whole thing is true. Whereas with and, both the first condition and the second condition must be true in order for this to be true. So if v is 3, we could say v is greater than 0 and v is less than 10. And that is true, right? Exclusive OR is a little bit tricky. You're probably not going to use it very much unless you like go into embedded systems design, because it has uses in like bit whacking operations. But essentially, what a XOR or exclusive OR operation does is if the two conditions come out differently, it returns true. If they come out the same, it returns false. So, for example, true XOR true is false. False XOR false is false. True XOR false is true. And false XOR true is also true. They should be careful with it XOR since it's a bitwise operator. Hi, David! I didn't know you were watching, David. Yeah. So, I don't really want to talk about bitwise with them, though, David. It's too soon! It's too soon to introduce them to the deep mysteries. They're only apprentices, David. They're only apprentices. We can't show them the deep magics just yet. We have to train them up first. Oh yeah. What does that mean? So very, very briefly, how this operates on true and false values can also be extended to the individual bits that represent the numbers. Likely none of you are thinking in binary by this point in time, but essentially, I'll have to do it and get it. Thanks, David, for sidetracking my lecture. Jeez. So let's say you had a number, right? And let's say you had another number. The XOR of these two would follow the same pattern as how XOR behaves on Booleans, right? So if they're different, you get a 1. If they're the same, you get a 0. So the result would be 1, 0, 0, 0, 0, 0, 0, 1 in this case. It doesn't make a whole lot of numerical sense. You know, if we were to convert these binary representations to integers, for example. This is in base 2. That's 108. This one is 230 or 237. And the result that you get is 129. So if you could figure out some some arithmetic operation that yields 129 from these two guys without referring to binary arithmetic, it probably isn't generalizable. Is exclusive OR like an implication from math reasoning? No. No, in formal logic, implication, if you have X implies Y, right? If X is true, and tabs would be more convenient. True, true, false, false, true, false, false. So true implies true is correct. false implies anything, but true cannot imply false. That's what the truth table looks like for implication. The truth table for exclusive OR looks like this. False, true, true, false. So if you want the logic, there you go. No, I wouldn't rely on that being applicable for all situations, no. It's not subtraction. It's absolutely not subtraction. It's P or Q and not P and Q. Yeah. Yes, essentially, Julia, thank you. But yeah. Anyway, so that's a lot of stuff that this is sort of, you know, there you go. So using these, we can construct Boolean equations, right? So this is kind of, again, related to your elementary logic. So this is a little bit of what's called propositional logic. So if we say B is I ate ice cream, C is I ate ketchup, B and C, I ate ice cream and ketchup, not B and C is I did not eat ice cream and ketchup, although I may have eaten either one of those. Not B is I did not eat ice cream. Not C is I did not eat ketchup. Not B or not C, either I did not eat ice cream or I did not eat ketchup. So again, you may have eaten either one of those, but not both. So there you go. So, quick question, which you can solve while I'm ruffling in my paperwork for the next slide deck. If x is true and y is false, what is the value of this expression? Leave it in the state it in the or actually, you know what? I'm going to do a survey. Stop. Boink. There you go. Solve this expression. Wait. Yes and no. True and false, rather. Thank you. Okay. 20 people have voted. So, 25 people have voted. So this is it. We have so if x is true and y is false, there we go. So not false is true. True and true is true. What's the precedent on that? Yeah. Not true is false. False or false is false. Not false is true. So the trues have it. Good. Any questions about that before we move on to the next set of lecture slides? Julia, yes, entering it into a calculator is cheating. But that's okay, because, you know. So, what would not false or true evaluate to? False or true is true. Not true is false. So, false. Ah, Python. Yeah, okay, not cheating then if you used Python. Because that's the class, right? So, like you can easily enter these types of things in Python, right? It's like, not false or true. It's false. There you go. Easy. So, let's talk about statements then. We've talked about expressions a fair amount. So we should have a simple we should have a basic working knowledge of how to compose numbers together in order to form expressions and have those expressions evaluated. Very important skill. Another very important skill is learning how to chain instructions together to form a program that does something more complicated. And that's what we're going to talk about in this lecture. This set of lecture slides. We're going to talk about conditionals and loops in particular in somewhat more detail. So, recall your structured flowcharts, right? Basic instruction, sequencing basic instructions, which is S then T, that's how you pronounce that. Start and end points are optional. Remember, we have selection, if B then S. Selection with something on the no branch, if B then S else T. And repetition, while B do S. So, in Python, this is how these things look, right? There. So this is the Python syntax. And I'm going to have to actually, I'm going to have to pull up a file. Winter. It certainly is winter. Get it topic 3'd up. I hate snow days. They set the whole schedule off. So, God almighty. There we go. So, if condition, you know, let's say B is true, if B colon tab, then some statement S, like x is equal to 7, right? So that's your regular if statement. Else y is equal to 4. That's your if then else. And there's one additional case as well. Let's say you had multiple conditions. Let's call them C, right? So if C1 that elif C2 x, let's move all of this, change it x. There. So this is an elif. This is a contraction of what other programming languages call this, which is else if. Python apparently thought it was extremely important to save those 3 characters. So in Python, it's called elif. So the way that an elif block works, the first condition that you test that is true opens up the statements immediately under it, and then it skips the rest of the else if block, right? So, if I were to say, you know, new tab, if I were to say C1 is equal to false, C2 is equal to false, Python 3 topic 3.py, then you would see the else case is the one that executes, right? Because this one failed, this one failed, this was the one you go with. Conversely, or in addition, if you make C2 true, you get 2, right? Otherwise, also, if you make C1 true, you get 1. So the trick is here, the first condition that you hit that comes out true, that selects which of these statements you're going to execute, regardless as to whether or not C2 is true. If C1 has executed, C2 will not be valid, that will not be considered valid, right? So, but you say, what if I want C2 to possibly be valid? Well, it's easy. You just replace the else ifs for regular ifs. And that way, let's just make it so that it does something interesting. Slightly more interesting. It will add each one of these, right? If I toggle C2 off, place false, there we go. You see, we get 4 because it's 1 plus 3. Right? So the middle one doesn't activate. So that's the difference between else ifs and regular ifs. Elif. And you can even omit the final else case if you want and just use elifs. There you go. Make sense? Hopefully that makes sense. So, the trick here, one of the tricky things about Python, is that the level of indentation that you use is absolutely important. It is the most important thing, because if everything's at one level of indentation, we can execute it and see what happens. We actually get an indentation error. After an if statement, it expects the next statement to be indented, and if it isn't, it knows something's wrong. There you go. Good. Excellent. So, yeah, you know, like, the lecture should be helpful, right? So it's possible to put if statements inside of if statements, right? So if, you know, x is equal to 2, then do something else, right? So to speak. So you have to keep track of what level of indentation you're on, right? The fact that this if statement is tabbed in by 1 means that, of course, it's a separate construct from the else if block that encloses it, right? And it's separately executed. It does not touch or interfere with these else's. It can even have its own. Because it's at a different level of indentation, like, this is a separate if block from the one that's enclosing it. It's called nesting. Like nesting, like Russian nesting dolls. Good. This is a concept that you'll have to use frequently, so I recommend you come to a certain degree of familiarity with it. So let's talk about let's talk about repetition then. So the basic and most easy example of repetition. Let's say I have I is 0, C is 0, while I is less than 10, C plus equals 1, or C plus equals I, and I plus equals 1. Print I, print C. There we go. If we execute this bad boy, I have an indentation. I have a problem. I have this stuff, which is not valid code. I'm sorry. There we go. All right. So I is 10. C is 45. Because if we take this guy over to, for example, Python Tutor, which I highly recommend that everybody use, especially if you're a newcomer to the programming world. As you go through this, right, C plus equals I, so it's still 0. I plus equals 1. C gets, whatever I is, it adds to C. So in the end, what this little tiny loop actually does is it expresses, 0 plus 1 plus 2 plus 3 all the way up to plus 9. There you go. So this is the adding factorial. Basically, yeah, if you want to make it into factorial, all you have to do is replace the addition operation for a multiplication operation, and this is the factorial function. Except if it were factorial, you'd have to start this at 1. Both of these at 1, because like anything multiplied by 0 is 0, so it just blows out your results completely, right? But yeah, there you go. That's factorial. Very good. I think factorial is one of our... Ha! It's the next... It was the next slide. So, nice little dovetail there. So, I'd need to turn the light on in this room. It's getting dark. Pardon me for just 2 seconds. So, in case you'd never covered this in high school, the factorial of a number is all of the numbers, including that number, from 1 to that number multiplied together. We can give that an inductive definition by saying the factorial of n is 1 if n is equal to 0, and it's n times n minus 1 factorial if n is greater than 0. So it turns out that you can actually encode factorial without using a loop, and I'll show you that right quick, just because it's interesting, and we'll have to talk about, we're going to talk about it later on in a couple of weeks anyway. This is called recursion, folks. Define factorial of n if n is equal to 0. Return 1. Otherwise, return, Elif, if, there we go, n is greater than 0, return n times n minus 1 factorial, else return 0. Why not? So, the factorial of 10 should come out to the same amount that it did above if we print it. I always forget to print it. Boom. Oh, interesting. Oh, yeah, because it was doing to 9 here, so I gotta put a here equals there, and boom! Now they're the same. So, this is called recursion. Notice that I'm not using a loop here, but I get the same effect as if I were using a loop. Any function which calls itself is called a recursive function. We're going to talk about recursive functions quite a lot more, because we have practically a whole unit on recursion, so we'll leave it for now, but I just wanted to show you that to sort of introduce the concept a little early so that it's perhaps a little less jarring later on. So the thing that's actually, the thing that's going on here is it's like the function call for 10 creates its own function call on 9, which creates its own function call on 8, which creates its own function call on 7, etc., 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 until it hits 0. Then it just returns 1. Then it crunches together all those multiplications that it created and gives you the final result. So that's how recursion works. Any questions? I have to say, the drop-off for people who are attending class concurrently has been quite steep, relative to other semesters that I've taught. Like 60 people, and I think at like our peak we hit like what, 68? Sure. That's about 1/4 of the class. The class has 240 people in it, approximately. Maybe 250? So, like, if you know people who are skipping class, tell them to get their butts to class. There's no excuse to not attend a class concurrently if it's online, people. Even if the time slot isn't particularly convenient. I have to be here, so I expect you to be. All of my classes are like this semester. I don't know, maybe it's just like the fatigue, but like, let me just point out for all you wonderful viewers out there in TV land, it's not easier to get your butt to an in-person class than it is to get your butt to a virtual class. You have to actually physically move your physical person to attend an in-person class. Will I put the lecture live or will I just record it? It's just going to be recorded. Classes are going to be in person starting next week, so my expectation is that people will come to the class. I have to, again, sorry, I have to go to the class, so I expect you to go to the class too. My environmental economics class started with 300 or 400 people, and yesterday the class had 29. Jeez. Kind of making me regret recording them. My 8:30 a.m. synchronous stats lecture has better attendance than this. In the assignments, it uses the pass function. Why exactly do we need the pass function for loops? You do not. The pass is just a placeholder. It's intended for you to delete it. It literally does nothing except remove the indentation error. So that, like pass is just in there so that the code you receive is syntactically correct and compiles when you receive it. It doesn't do anything. It has no purpose. You are free to delete it. Yeah. Yeah, it's, we'll see how it goes, eh? I have a... Yeah, you can totally erase the pass. Yeah. Um, I have a theory about this, actually. Um, oh, what was it? I'm forgetting what I was gonna say. Oh, for this particular class, I think I know why the attendance is low. Because we've started from, like, such bare basics, I think a lot of people have looked at the material and they've said, "Oh, this is easy. I know this," and then they just don't come to class. These people will be begging for mercy by the time they hit assignment 4. Believe me. Oh, thank you, Daniel. Stop. You're too kind. You're too kind. Yeah. All my online lectures have significantly dwindled in size, but that might change as we go to in-person. Well, like I've been in the system for... I've been teaching in the system for a while, and let me tell you, generally speaking, the number of people that actually come to class, it tends to be an exponential decay. Like, if I kept track of the attendance to all of my lectures, I could calculate the half-life of my lecture. Right? Like, that's, like, it's like a scientific law. That's how well it normally fits in exponential decay. But, yeah. I don't know. Let's see. Just to make sure, if you submitted on the assignment on Jupyter, you don't need to submit again on Avenue. Yes, correct. So we can get extra marks for attending this class? No. You get to not fail the midterm. That is my gift to you. Is there a way to check if you submitted the assignment correctly on Jupyter? It should show you your submissions. If you go to the tab where you fetch the assignment, that if you look at the submission button underneath that, there should be a bunch of, like, all of the different submissions that you've made should be listed. We only take the most recent one. Prof, what if they're just going to watch the lectures later? It's still not as good as coming in person, like coming at the time. I know that everybody has room in their schedule in it, because the registrar makes sure that you have room in your schedule for the class, or else you can't take it. So there's, yeah, the whole having the class available after the class has occurred thing is meant to allow you to recap stuff that you might not have understood. It's not meant to be, like, it's not meant to allow people to just procrastinate, right? And this is just procrastination. And procrastinators will eventually get theirs. And you can clip that for a meme compilation. Technically extra marks if you don't fail the midterm. Yeah. I can access assignment 2 on JHub, but just submitting it using a local installation. Yes, this is so that everybody has to go through the process of doing a offline submission or through Avenue submission, because sometimes when we have a test, the JHub server can't handle the load and it crashes sometimes. Just for like an hour or two, but that's really a lot to somebody who's writing a test, you know? So by having assignment 2 as submission must be through Avenue, nobody can tell me on a test that they have no idea how to submit something through Avenue if Jupyter goes down. It's insurance for me. I should stop recording and drop some test hints. Yeah. Nah. You learn more when you're present. You also have the ability to engage in the class, interact with the class, ask questions. Like, I can't can't understate the importance of being able to ask questions. And if you don't come at the time, you can't ask questions. And if you can't ask questions, you can't get your questions answered. So there you go. Sir, does the university provide laptops? Because the laptop I have has a broken screen, and I can only see what... Does the university provide laptops? I think you can rent them from the library, but, you know, quality is going to vary. Do they provide laptops to students? This institution, which is already taking thousands and thousands of dollars from you. And that was, that's none of my business, T-sip. No, Hossam, I think you should probably go get one. You can rent them from the laptop, but you have to give them back at the end of the day, I think. And you can't let them leave the library. I think that's... I can't remember, but I think that's how it works. I dropped my laptop down the stairs in Mills, and the top of the screen is peeling off. Oof. Oof. Yeah. Yeah, you have to get assignment 2 from Avenue. Work with the file, as it were. All right. I think I'm done, folks. Have a good weekend. Work hard on the assignment. Work hard in the mines of in the digital mine. Have fun hitting bricks by tapping your keyboard. Yeah. All of the assignments are available through the assignment tab, Dropbox. It's like, you know what I'm talking about. Take her easy, folks. Peace out.